I'm Kumar K, your favorite DSA teacher when it comes to solving hard and seen DSA problems of online assessment, OA rounds, and comparative programming. So today, guys, we are going to solve a very hard level problem. Okay, it was asked in recent Code 9 Codeforces Div 1 plus Div 2 round, and this is a master level round. Okay, master level problem. So the thing is that, guys, the rating of this problem is somewhere from 2200 to 2300, which has the potential to make you master or even international master on code forces. This problem is very difficult and it needs lots of prerequisites like you need to know dynamic programming, maths, combinatorics. Also, you should be able to make deep level observations. So most of the people were not able to solve it and even not able to understand its solution. So no matter who you are, I'll try to explain it to you from a very beginner scratch level so you understand it in a nice manner. So if you find this video useful, make sure to like and subscribe. Also, guys, about me, I am Kumar K. I have previously worked at Amazon and Media.net as software engineer. I cracked those offers off campus despite being from a Tier 4 college. Also, I have All India Rank 12 in Google Code Jam 2021 and All India Rank 4 in the recent Facebook Hacker Cup. So let's go to the question. The name of the question is Shohag loves inversions. Guys, before that, guys, let's congratulate our students who just 2 weeks back cracked the offer from Google. Google asks the toughest OA, okay, and toughest DSA questions in their interview rounds. But my student Shivam did it. So congratulations to Shivam from our Desi 20 cohort for cracking Google. Then comes the next selection, guys. Abhirami. My student Abhirami has cracked off-campus offer from Amazon. Okay, so she was a beginner, but after 8 months of training, referral support, and everything else, she cracked the offer off campus from Amazon. Also, guys, congratulations to student Aditya Gupta. He has cracked an offer from DirectEye. DirectEye also asked the hardest unseen DSA questions in their OA and interview. But after high level good training, these people managed to crack those offers. So if you are also interested in best level DSA, hard level DSA, easy level DSA, medium level DSA, OA, CP training, system design training, full stack development training, if you want one-to-one mentorship, personal help before your interview test, and many more things like support, mock interviews, and referrals of top 500 companies, you can join our program. The link is in the description. So now let's go towards the question. So, guys, the question is saying that you are given a starting array 0 comma 1. At each step you have to calculate the number of inversions of this array. Insert k anywhere you want in the array. Output the number of distinct arrays which can be formed of size n by doing this process. Okay, so guys, first let's clear up the meaning of inversion. Okay, so even if this is a Codeforces E problem of very high rating, still let's try to make the process easy. So if I give you any binary array like this, let's say 1 0 0 1. Okay, so any pair I comma j such that I is 1 and j is 0 and I is less than j. So basically, if 0 is here and on the left hand side there is a 1, then this pair will become one pair of inversion. Okay, so let's see how many inversions are there in this binary array. So if you check this binary array, this is one inversion, right? 1 comma 0 inversion, because 1 is on the left hand side, 0 on the right hand side. This is the next inversion, second inversion. This is the third inversion, and yeah, that's it. So in this array, guys, if you check carefully, there are total 3 inversions. So inv equal to 3. So guys, hopefully the first concept required for the problem is clear to you people. Okay, go towards the second concepts where we do the simulation. So the initial array is given to a 0 and 1. It is given in the question also. You are given the initial array 0 and 1. So your size of the array is 2. If you try to insert a 0, it will look like 0 1 0. If you try to insert 0 here, it will look like 0 1 0. And similarly, if you try to insert a 0 before 1, it will look like 0 0 1. Now you might think that, sir, can we insert 0 here? Yes, you can insert here, then it will look like 0 0 1. Similarly, guys, now the first array has inversion 1, so you can insert 1. The second array has inversion 0, so you can insert 0. 0 you can insert at the back, it will look like 0 0 1 0. 1 here you can insert at this position 0 1 0 1. Then 1 you can insert here 0 1 1 0. Then 1 you can insert ahead 1 0 1 0. But make sure that if you insert 1 here after this one, or if you insert this one here after this one, does not matter, they look the same. We are only counting the distinct arrays. 0, if we insert the 0 here, it is triple zero one. And if we insert the 0 at the back, it is 0010. But if you insert the 0 here, then also it is triple zero one. And if you insert the 0 here, then it is also triple zero one. So the total number of distinct arrays when we reach n equal to 4 is 1, 2, 3, 4, and 5. So total 5 distinct arrays are there. Okay. So hopefully this concept is also clear to you. Now guys, in this problem, what is the biggest observation we can do? The biggest observation we can do is, guys, that we have to see this is the initial array of size n equal to 2. Okay, let's say the question is telling you to calculate all the valid unique arrays of n equal to 5 after this process is done. So the final array is all will be of size 5, right? They all will be of size 5. Okay. Now guys, how many of these arrays will have their inversion as 0? How many of those arrays will have their inversions as 0? My claim is that only one array in the final will have inversion 0. And that array will look like this. The array will look like this. 0, 0, 0, 0, 1. So this is the array having inversion 1. Similarly guys, this is the array having inversion 0. Okay. Now, the next thing which is very very important is that this is the main observation, that no matter what is your current n, the final n will only have one array which has an inversion 0. There is no other array you can build whose inversion is 0. Why? Its inversion is what? Its inversion is 0. So you can insert 0 where? If you insert a 0 here, the inversion of this array will become 1. Then you can never reach this stage at a larger number with inversion 0, because the inversion can only increase. The biggest observation is that whenever you insert a number, the inversion can only increase. So you cannot put 0 after 1 if you want to maintain the inversion as 0 only when you reach till n equal to 5. So you will put the inversion is 0, you will put 0 in the middle, it will look like 0, 0, 1. Then you will again put here the inversion is 0, again put 0 like this, 0, 0, 0, 0, 1. Then you will again put 0 because the inversion of this is 0 here, then it looks like this. So for n equal to 5, this is the array which has inversion 0. Similarly, guys, we need to count the arrays which are having inversion 1, inversion 2, inversion 3, inversion 4. So, guys, let's say n equal to 5 is given. So, what you have to calculate? All valid arrays whose inversion is 0 plus all valid arrays whose finally after all the process their inversion will be 1. Then all the valid arrays who will finally after all the process will have their inversion as 2. Similarly guys, till the end, okay, there can be many inversions till n square somewhere around. So no matter what n is given to you guys, okay, so hopefully this is clear to you guys that no matter whatever n is given to you, what will you do first? क्या करोगे आप सबसे पहले? आप पहले काउंट करो the number of arrays of size n which have inversion 0. There is one array like that. Count the number of arrays of size n in the finale which will have inversion 1. Then count the number of arrays in the finale which will have inversion 2, 3, 4, 5 till the end. Okay. So for we are able to solve this problem if you just want to count the valid arrays of size n whose inversion will be 0 after the process. But guys, what about the valid arrays of size n whose inversion will be 1? So now comes the interesting process. Let's do it for inversion equal to 1. So for inversion equal to 1, guys, you need to maintain the inversion as 1. So the common sense will give you the answer here. So here we come. Where will you insert the 0 so that the inversion becomes 1? You can only insert at the back, right? So 0, 1, 0. Okay, great. Now the value of this thing has become, inversion has become 1. So where will you insert 1 so that the inversion remains 1? You can only insert at the back. You cannot insert here. If you insert 1 here, the inversion will become 2 because 0, 1, 1 pair, 0, 1, 1 pair, 2 pairs. Nor can you insert the one here, nor can you insert the one at the start, because there again the inversion will become 2. We have to maintain the constant number of inversion 1. So hopefully you understand that we have to maintain the constant number of inversions 1 till we reach the end. So only option is put 1 in the back. Then again the inversion of this is 1, so you again put 1 in the back. Again the inversions of this is 1 because only one valid pair is there, right? So again you put 1 in the back. So the claim is that, guys, for any value of n, let's say n equal to 5, these are the arrays whose inversion is 1. Which are those arrays? This pair is generating one inversion. Second, you can reach a final array which looks like this: 0 0, 1 here, then this 0, then 1 here. The one inversion here you can see. Okay, guys, similarly this one will keep on coming ahead. Okay, I hope you will remember this pattern. This 101 will keep on coming ahead. Okay, that's it, guys. That's it. Now you cannot say that, sir, can we reach this position? No, no, you can never reach this position. This is not allowed. 1 0 will always be at the start. It's a homework for you to figure out why the 1 0 will always be there. Because your process started from 0 comma 1 na. So if you maintain the, if you see, at max you can reach positions like 0 0 0 0 1, and then you can put a 0. Then only once you can put, once the inversion becomes 1. So you are not able to put 1 at the start. Okay, then the inversion will become 2, right? Or it will become greater than 1. So guys, these are the n minus 2 inversions. So for any n, there will be n minus 2 inversions whose there will be n minus 2 sequences whose inversion is 1. Okay. So guys, now the problem has been solved roughly for half of the cases actually. Yeah, you must be thinking that, sir, we have only solved for 0 and 1, but how did it solve for half of the cases? So I will show you that. See, for n equal to 6, now you know how many valid arrays are there, guys, whose inversion is 0. There is one valid array. I know that: 0 0 0 0 1 2 3 4 5 1. How many valid arrays are there whose inversion is 1? N minus 2. So 4 are there. I'm not drawing them. I hope you know. Always start like this. Okay. And slowly this 1 0 will keep on coming ahead. Okay. Okay. So there will be 4. Okay. You know now? Like 0 0 0. Then 0 1 0. Then this 1 0 comes here, then this 1 0 comes here, like this, then this 1 0 comes here. Here there will be 0 0 0, then 1 here, then 1 here, 1 here, then 0 0. In the starting there will be zeros, and then there will be ones. Okay, so like this, guys, there will be 4 arrays in the finale of size 6 which are having inversion as 1. So hopefully till here you have understood all the concepts. Okay, now guys, the thing is that the number of valid sequences of length n having zero inversion, there is only one possible sequence like that. The number of valid sequences of length n having one inversion, there are n minus 2 such sequences. So the total number of valid sequences of length n, okay, the total number of valid sequences of length n having less than equal to 1 inversion means either 0 inversion or 1 inversion. It is 1 plus n minus 1, 1 plus n minus 2, which is n minus 1. Now, guys, our next task should be to count the number of inversions, number of sequences which are having inversion greater than equal to 2. So let's try to do it for n equal to 5. So guys, for n equal to 5, you can see the valid sequences having 0 inversion. There is only one such sequence. Okay. Number of valid sequences of length 5 having 1 inversion, there are n minus 1 such sequences. So total number will be n minus 2. Now let's try to calculate all the valid sequences whose inversion is greater than equal to 2. So guys, the first part is very, very important, and that part is that the valid sequences of length 5 having inversion greater than equal to 2 can be generated from the sequences of length 4 having inversion 1. So which are the sequences of length 4 having inversion 1? These are the two sequences of length 4 having inversion 1. These are the two sequences, guys. These are the two sequences. See, this one, you remember it, right? And this one. These are the two sequences, okay? So be very, very careful now. These are the two sequences of length 4 having inversion 1. Now, guys, where can you put, see, they have inversion 1, so where can you insert a 1 so that their inversion becomes greater than equal to 2? If their inversion becomes greater than 2, their size will also become 5, na? So they will become a part of valid sequences. If in these two sequences now you are able to insert one smartly, na, they will become of size 5 and their inversion will become greater than equal to 2. So if you focus on the sequences having length 4, having inversion 1, these are the two sequences. So where can I insert one? I can insert one here. I cannot insert at the back because the it will not be unique. One will look the same. So I can insert one here. Then I can insert one here, and I can insert one here. So three places possible. Okay, these three after the first one, and in this sequence we can add two places possible. We can put a one here and we can put a one here, and the inversion will become greater than equal to 2. So guys, the basic observation is that if you want to know the valid sequences of length phi such that their inversions are greater than equal to 2, such that their inversions are greater than equal to 2, all you need to focus is on the sequences of length 4 who are having inversion 1. Find how many ways are there to manipulate the sequences of length 4 having inversion 1 containing only 0 and 1. How many ways are there to manipulate them so that, obviously if you insert one more number it will become of size 5. You can see the dp, it will become of size 5, and the inversions are gonna increase. Inversion can only increase, that is the biggest observation. Whenever you insert a number, the inversion can only increase. Okay, so the why are we doing separately for I greater than equal to 2? Because this is the observation is that this is very important observation that once the inversions become greater than equal to 2, na, it is fixed that the max element of the array is always less than equal to number of inversions. You can try this with any array which is having any inversion as 2. Now you will only put 2, which 2 is bigger than all the zeros and ones. So the things become easy. So the valid sequences of length phi having greater than equal to 2 inversions is nothing but the number of ways to manipulate all the sequences of length 4 having one inversion. And we know which sequences are they. We know the 101 pattern. All the guys having one inversion, we know their pattern. Okay, so there are 5 such ways. See, this is 0010 and then 0101 till the first 0. Okay, so 3 ways here and then 2 ways here, so 3 plus 2. Guys, then there are another set of numbers also which can contribute to valid sequences of 5 having greater than equal to 2 inversions. So which are they? Guys, they are the numbers of length 4 only, but they are having greater than equal to 2 inversions already, and they only contain 0 and 1. So guys, these 0110 and 1010, so 0110, 0110, these are the another set of ways. The first set clear, right? The first set was very clear, right? So this was nothing but what? See, valid, the number of sequences of length 5 which are valid such that they're having greater than equal to 2 inversions. The first way is manipulate all the sequences which are valid of length 4 and having one inversion, manipulating them in such a way such that the inversion becomes greater than equal to 2, and obviously if you insert one number the length will become 5, so 5I greater than equal to 2 will become this only which you want. Another way is, guys, all the valid sequences of length 4 having inversion greater than equal to 2. So which are they? They are these guys. Ram Ram. They are these guys. So let me show you those guys. They are these guys. 0110 and 1010. So 0110, 0110 and 1010. Okay. So 0110 and 0110 and 1010. So they have inversion as greater than equal to 2. You can check. One pair, two pair. Okay. And here you can also check one pair, two pair. Okay. Now their inversion is 2. So where can you insert a 2, guys? There are five places to insert a 2, and the inversion will only increase. You can insert 2 here, inversion will remain as it is if you insert 2 there. If you insert 2 here, inversion will become 3. Why? Because there is one number less than 2 on the right hand side. Then you can put a 2 here, then you can put a 2 here, or you can put a 2 here. What happens when you put a 2 here? Earlier the inversions were how many? 2. Now this is also inversion, this. So 4 inversions added, 6 inversions. So basically, how many places are there to put a new 2? There are 5 places to put a new 2. So guys, there are 5 options to put a 2 in this sequence, and there are 5 options to put a 2 in this sequence. So total there are 5 into 2 sequences. Okay. So I hope that that is also clear to you till now. Everything is going so great and so nice. So now, valid phi I greater than equal to 2 is nothing but the valid sequences having their inversions already greater than equal to 2, but they only contain zeros and ones into the number of ways you can make them of length phi. So basically तुम दो को कहाँ कहाँ डाल सकते हो, 5 जगह डाल सकते हो ना. So 2 into phi. So guys, total answer will be n minus 1 plus phi into 1 plus 2 into phi equal to 19. So guys, now let's solve it for n equal to 6. Now guys, you are smart, you know how to solve it. Okay, n equal to 6. So guys, like I want you to stop for a minute and think about yourself, on yourself, how to solve it. So for n equal to 6, guys, see the valid sequences of 6 having I equal to 0, you know it is 1. Valid sequences of length 6 having I equal to 1, you know it is n minus 1. So the total is it is n minus 2. Ram Ram. God is always very, very important. Okay, always focus on God. So guys, you know this basic things, and basically I'm trying to say that that all the valid sequences such that their inversion is less than equal to 1, either 0 or 1, their total number is n minus 1. Now guys, how will you calculate valid sequences of 6 such that the inversions are greater than equal to 2? See, there will be 3 divisions. Okay, one will be the valid sequences of length phi whose inversion is 1. Obviously they only contain 0 and 1. Okay, okay, the number of ways to manipulate them, which is a formula you can easily figure out. How? Guys, which are the sequences which are of length 5 and having their inversion as 1? So these are the sequences you can see. These are the sequences which you can see. Let me show you. These are the sequences of length phi having inversion 1. See guys, this 0 0 1 0, then 1 0 will keep on going ahead, keep on going ahead. So initially there will be 4 ways to put 1 here, so that the inversion becomes greater than or equal to 2 and the size becomes 6. And here 3 ways, 2 ways. So guys, this is 4 plus 3 plus 2. This is nothing but the sum of increasing arithmetic sequence like n into n plus 1 by 2. You can put that formula here and get the answer. Okay, so this thing is pretty simple. Okay, the valid number of ways of the sequences of length 5 valid which are having inversion 1. Then the second way will be what? All the sequences, very very important, this is of length 5 having their inversion greater than or equal to 2, multiplied by the number of ways you can make the length phi to length 6. Another will be what? Number of valid sequences of length 4 already having their inversion greater than or equal to 2, only containing 0 and 1. Here also only containing 0 and 1. Multiplied by the number of ways you can make in a sequence of length 4 into length 6. Now guys, number of valid sequences of length 3 such that they are having greater than or equal to 2 inversions, multiplied by number of ways you can make a sequence of length 3 into a sequence of length 6. But guys, number of sequences of length 3 having greater than or equal to 2 inversion, there are zero such sequences. There are no such sequences. Okay, there are no such sequences. So you only need to go till 4. Okay, only need to go till 4 and the problem gets solved. Actually, it's so simple, man. So guys, let's go towards our final observations. For if you want to solve this problem, for n equal to 6, what will be the answer? You know that the number of valid sequences of length phi having one inversion, number of ways to manipulate them. So I have written that, okay, number of ways to manipulate them. Then number of sequences of length phi, okay, having greater than equal to 2 inversion, but they should only contain zeros and 1. All those sequences, when you get them, you should know the number of ways to make the sequence of length phi to number of length 6. So this thing I have written here. Then the number of sequences of length 4, having their, inversions greater than equal to 2, but only having 0 and 1. Once you know all these sequences, you should know the number of ways to make them from length 4 to length 6, because we want length 6 I greater than equal to 2. Okay, so this thing I hope is pretty much clear to all of you, and you guys are really enjoying. Now, guys, the thing is that dp4 means number of ways to make a sequence of length 4 to length 6. Dp of 5 should mean the number of ways to make the sequence of length 5 to length 6. So basically, n, if there is n, dp of 5 should be the number of ways to make a sequence of length 5 equal to length n. Dp of 4 should be the number of ways to make a sequence of length 4 equal to length n. And dp of 6 will be 1 only, because you don't need to change the sequence of length n, okay? So let's try to, guys, observe how can we do that. So guys, let's say I give you any sequence of length phi, okay? So let me give you any sequence of length phi. How many ways are there? If I give you any sequence of length phi like y1, y2, y3, y4, y5, okay? Now it is known that for the sequence, their inversion is greater than equal to 2. So the new number which is coming, it is greater than 2 or greater than equal to 2. So you can put it anywhere, okay? You can put it anywhere, and the inversions will only increase. So guys, what are the number of ways to make it of length 6? You can use common sense and you will get the answer. You can put the new number here or here or here or here or here or here. So that's why dp of 5 is 6. There are 6 places to put the new number. And dp of 6 is 1. Why? Guys, if you already have a sequence of length 6, then you don't have to do anything. dp of 6 is 1. Interesting part is, what will you do if you have 4 number? Okay. This is the sequence of length 4. How will you make it into a sequence of length 6? Once you have all the valid sequences of length 4 which only contain 0 and 1 and whose inversions are greater than equal to 2, you have them. Now how will you insert a number greater than equal to 2, because the inversion of all of them is greater than equal to 2, so the new number being inserted is greater than equal to 2. How will you insert the number in this 2 times so that it becomes 6? So guys, the option is pretty simple. One option is what? One option is what? One option is that you can insert the number 2. Okay, the number greater than equal to 2, let's call it z. You can insert z here and z here, so it will become of length 6. Inversion will remain the same, because z does not affect the inversion if we put at the end, okay? Because it is bigger than all the numbers y1, y2, y3, y4 explained in the start. So one way is to put 2z in the end. Another way is what, guys? You can put the z here, or you can put here, or you can put here, or you can put here. So there are 4 ways to put a z, right? So guys, if you put a z here, what is going to happen? They will become of size phi. They will become of size phi. And once they become size phi, you know how to make them 5 to 6, which is dp of phi. So answer will be what? Answer will be one special way plus 4 into dp of phi. But guys, there is one more corner case. You can put one z here, but then you can put one z in the end also, right? Because in putting in the end doesn't affect the inversions. If you put one z here and then in the end it becomes of length 6. Another way is what? You put the first z here and then the next z again in the end. Another way is what? You put the first z here and the next z again in the end. Another way is what? You put the first z here and the next z again in the end. So in these cases, there are again 4 ways which lead you directly to 6. So 4 into dp of 6. So guys, dp of 4 is what? See, such a brilliant problem. This is on super high level mathematics, combinatorics, dynamic programming, which you must not have seen these kind of stuff. So the formula for dp of 4, and using this you can calculate formula for each index I, is nothing but what? Kumar K, Karan, Ram Ram. So it is nothing but one special way to put the two same numbers in the back as Z. Then 1 plus and guys, how can you generate these sequences? Let's do a last homework with you people. Okay, let's say you want to generate all the valid sequences of length 7. Okay, or let's say all the valid sequences of length 8. Okay, so what will be the answer? Valid sequences of length 8 with I less than equal to 1. We already know that, n minus 1. Then valid sequences of length 8 having I greater than equal to 2 is nothing but valid sequences of length 7 having their inversion as 1. Number of ways to manipulate it. Number of ways to manipulate it. Then valid sequences of length 7 having their inversion as 2. Okay, having their inversions as greater than equal to 2, only containing 0 and 1, multiplied by dp of 6, dp of 7, which will tell me the number of ways to convert the sequence of length 7 into length 8. Okay, then number of sequences of length 6 whose inversion is greater than equal to 2, but they only contain zeros and ones. Okay, they all become distinct. That's why we are doing this, multiplied by number of ways to, and guys, like this, till 4. So hopefully guys you enjoyed this problem. I am having a little bit of cold and sick, but hopefully you enjoyed this problem. Okay, take care. And yeah, this is a 2200 to 2300 rated problem. Make sure you comment in the video if you like this problem and the solution video. Take care. Love you all. Good night. Ram Ram.